Welcome back, Algebra 2. We are going to finish the 5.2 notes. So if you did not watch part 1, please make sure you guys go back and watch part 1 because these problems definitely ramp it up in terms of difficulty. Okay, so 4 and 5 are just, again, asking you to find the inverse and then find the domain and range of both the original function and the inverse. So first thing I like to do is just rewrite. Instead of writing f of x, I like to just write y equals 2x over 5x minus 7. Now, this one's a little bit more complicated because there's two x's. So when I start to solve for the inverse, when I swap my x and y's, the y is going to be x, and both of those x's are going to turn into y's. So it's going to be 2y over 5y minus 7. So because there was two x's, we swapped into y's for our inverse. Okay, so now that's our first step. That's the easy step, right? Is just like swapping the x and y values. Now what we need to do is to get y by itself. Now, typically, I'd have you guys talk to your partner. What do you think you should do? But since we don't really have that right now, I'm just going to kind of go through the process with you of how you're going to get y by itself. Now, what's challenging is recognizing, okay, there's two y's. How do I isolate a y? So the first thing that we're going to do is get rid of the denominator. And we're going to do that by multiplying both sides by the denominator. So multiply here by 5y minus 7 and here by 5y minus 7. So I get x times 5y minus 7 equals 2y. Okay, so from there, I would distribute. I distribute my x to the 5y, and x to the 7. And I get 5xy minus 7x equals 2y. Now, again, what's complicated here is that we're trying to get y by itself. We have a y here, we have a y here. So what I want to do is I actually want to move it so I have all of my y terms on one side of the equation, and anything that doesn't have a y, I'm going to move to the other side. So I'm going to start by just subtracting the 2y. I'm going to move it to the left side. So now I have a y, I've met both of my y's. Now negative 7x doesn't have a y term, so what I'm going to do is move it to the other side. I'm going to add 7x to both sides. Okay, so now that my y terms are on the same side of the equation, I notice, okay, 5xy minus 2y, they both have a y. And whenever something has something in common, called the greatest common factor, we can factor out that y. So we're going to factor out the y, and I'm left with 5x minus 2, and then equals 7x. Now that I factored out a y, how can I get y by itself? Well, I can divide both sides by this expression, 5x minus 2. And that will get me y by itself. And that's my answer, and that's my inverse. So here's the deal. That seems like a lot. I will say these types of problems are super similar. Like there isn't really like anything that like any variation really with these types of problems where there's two variables. So you're always like first moving over the denominator, distribute. You want to get all of the y terms on one side of the equation. So I'll write that because that's super important. Get all y terms to one side of the equation. which is what we did here and here. So all of the y terms are on one side of the equation, and then you're always going to factor out a y. And then you'll divide and get y by itself, and that will always be the inverse. Okay, so now the second part of these is always just finding the domain of the original and then the domain of the inverse. So let's start with the domain of the original, which is 2x over 5x minus 7. Now we're first thinking, is this a polynomial, a radical, or rational? And because there's a variable in the denominator, it is a rational expression. So since it's a radical function, that means we have to find its excluded values. So remember, we're looking at the original, so this would be finding the excluded values of the denominator. So 5x minus 7 can't be equal to 0. So we'd add 7, divide by 5, and that's my excluded value. So the way that we write that in interval notation, so it can be every single number except 7/5. So it's negative infinity to 7/5. Sorry, it was not letting me write well. And then 7/5 to infinity. Now, before we get to the range, because remember the range is the domain of the inverse, I'm going to just write then, I'll write that, but then leave it blank. So we're going to do the domain of the inverse next. Okay, so the domain of the inverse, we'd look at the inverse function. And again, it's a rational function. So we would want to set the denominator equal to 0 to find the excluded values. So it'd be 5x minus 2 can't be equal to 0. Add 2 to both sides. X can't be equal to 2/5. So then that's my domain. So again, it's that negative infinity to 2/5 union 2/5 to infinity. So now that we have the domain of both of them, we can find the range of both too. So remember, the domain of the inverse is the range of the original. So if the domain is this, we can just write it there. Negative infinity to 2/5 union 2/5 to infinity. So these always are going to be the same. And then the range of the inverse is always going to be the domain of the original. So negative infinity to 7/5 union 7/5 to infinity. So you're always using one of the domains to find one of the ranges, and it's always just the opposite one. And that's it for 4. So, okay, so let's move to 5. If you guys are feeling super good with 4, 5 is really similar. So it follows the same pattern, same with the domain, all that stuff. So if you're feeling good, you guys can try it on your own. Pause me here, do what you can do, and then come back and check your work. If you need that extra explanation, then, I'm going to explain it here. So, okay. For number 5, first thing I'm going to do is just rewrite it. And then I'll start with my inverse. So my inverse, remember, we're just swapping the x and y values. So this is going to be x equals 2y plus 3 over y plus 2. Now, first step, just like the problem on number 4, is to get rid of the denominator. So we're going to multiply both sides by y plus 2. So it's going to be x times y plus 2 equals 2y plus 3. And then, just like the other problem, I'm going to distribute the x to both terms. So I have xy plus 2x equals 2y plus 3. Then I'm going to start by moving all my y terms to one side of the equation. So I'm going to move this 2y to the other side. And then anything that's not a y term, I'm going to move to the other side. So I'm going to move this 2x to the other side. If you have 3 minus 2x, that's fine. I just prefer to have like the x terms first and then the numbers. That's standard form, right? So that's just how I like to write it. So now that on the left side, we have both of the y terms. So that means just any term that has a y attached to it, I can factor out their GCF. Their GCF is y. And so now the way that I get y by itself is dividing both sides by x minus 2. And so now y is by itself, and I have the inverse. So my answer here is negative 2x plus 3 over x minus 2. And that's it. That is my inverse. So now if you guys, once you get here, I want you guys to pause me here, and I want you guys to find the domain and range of both the original function and the inverse. So pause me here, try that on your own, and then come back and check your work. Okay, so you should be coming back to check your work because I really do want you guys to be trying these on your own. And so let's start thinking about them. So the domain of the original. Okay, so magic of movies. The domain of the original, remember, we're looking at, it's a rational function. So we're looking at the excluded values. So that would be x plus 2 can't be equal to 0. So that just means x can't be equal to negative 2. So the way that we write that is negative infinity to negative 2 union negative 2 to infinity. And I can use that to fill in now, okay, that's also the range of the inverse. The domain of the original is always the range of the inverse. Okay, so then we need to find the domain of the original, of the inverse. And that's looking at this denominator, which is x minus 2. So x minus 2 can't be equal to 0. We add 2, and x can't be equal to 2. So the domain here is negative infinity to 2, union 2 to infinity. And then the range here is going to be the same as the domain of the inverse, negative infinity to 2, union 2 to infinity. And that's it. So that is that's your notes for 5-2. If you guys have any questions, please make sure you bring them to office hours or email me, whatever you guys need. Happy to help in any way. So I hope everyone's doing well. I still haven't decided on a new show. I've been kind of catching up on my regular shows that I watch. So I haven't been binging anything new. So I hope you guys are doing great, and I'll talk to you soon.